Topic Fourier series. If you take a signal, so I will consider a signal like this. Let this be origin and positive. This is x-axis. I am taking x-axis. This be y-axis. This be y-axis. Right side it is 1, 2, 3, 4, etc. -1, -2, -3, -4 like that. So this is 1 unit time duration. This is again 1 unit, again 1 unit. So this is a periodic signal. This is a periodic signal, and let the signal be x of t. Let the signal be x of t. In any signal, let this be height 4 units. Height is 4 units. For any signal, we have the parameters like amplitude and frequency, phase angle. For any signal, we have all these are parameters of the signal which give characteristics of the signal. And this is also a periodic signal. Given signal is also a periodic signal because the same thing is getting repeated again and again. And if all these parameters exist, and it is a periodic signal, we can represent this using cosine, sine, and exponential terms. For a periodic signal, the amplitude, frequency, and time period can be expressed in terms of cosine terms, sine terms, and exponential terms, and that is called as Fourier series. It should be a periodic signal, and the amplitude, frequency, and phase angle are represented using cosine, sine, and exponential terms. It is said to be Fourier series. And for a Fourier series to exist for any signal, Fourier series exists based on some conditions. And those conditions are: the first condition, signal should have minimum number of finite number of maxima and minima. And the signal should have finite number of discontinuities. And third condition, signal should be absolutely integrable over one time period. Should be absolutely integrable over one time period, capital T. So in the given signal, time period is nothing but one positive and negative half cycle, on time, off time. This is called time period. Over one time period, it should be absolutely integrable, which means the signal name I have taken x of t. So mod x of t dt, if I take over one time period, this integration should be a finite value. This is less than infinity. Less than infinity means a finite value. This is an equation. So these three conditions, if the signal satisfies, only then we can apply Fourier series. If it is a periodic signal, it follows. If it is a periodic signal, the last point decides whether it is periodic or not, because we are using the integration limits 0 to t. So it will take care of the periodic signal or not. Okay. And coming to, we know that periodic signals are power signals, aperiodic signals are energy signals. For energy signals, the energy will be infinite value. For energy signals, energy is finite value, power is infinite value. Okay. So those things can be taken care in this last equation, whether the signal is periodic or not. Other than that, the signal should have maxima, minima finite in number, and it should have finite number of discontinuities. These three conditions should be satisfied. Only then we can apply Fourier series on any signal. These three conditions are also called as Dirichlet conditions. These three conditions are also called as Dirichlet conditions. If it satisfies Dirichlet conditions, then Fourier series can be applied. Then Fourier series can be applied for the signal. Okay, signal should satisfy the Dirichlet conditions. Only then Fourier series can be applied on a signal. Okay. Now I am going to the further discussion on Fourier series. So we have different types of Fourier series representation. Different types of Fourier series representation. First type is trigonometric Fourier series. First type is trigonometric Fourier series. Second one is exponential Fourier series. Exponential Fourier series. So if you take trigonometric Fourier series, I told you signal can be represented using cosine and sine terms. So it is nothing but a naught plus summation n equal to 1 to infinite an cos n omega t plus bn sin n omega t. This is the representation in trigonometric Fourier series. So exponential Fourier series, the signal can be represented as summation n equal to minus infinite to plus infinite Cn e power jn omega t, e power jn omega t. So this be equation number 1, trigonometric Fourier series. This be equation number 2, exponential Fourier series. In equation 1, we have some constants. A naught, an, and bn. These are calculated as 1 by t integration 0 to t x of t dt. An is calculated as 2 by t integration 0 to t x of t cos n omega t dt. And bn is calculated as 2 by t integration 0 to t and x of t sin n omega t dt. These are about trigonometric Fourier series. In equation 2, exponential Fourier series. Okay. So this we can have the coefficients or constants. Coefficients or constants similar to a naught, an, bn. In exponential Fourier series, the coefficients or constants are c naught, c positive suffix n, c negative suffix n. If you say c naught, it is the same formula. C naught can be calculated as 1 by t integration x of t dt. 0 to t is the integration limit. If you have c plus n to be calculated, it is 1 by t integration 0 to t x of t e power minus jn omega t dt. And if you take c minus n coefficient you want, it is 1 by t integration 0 to t x of t e power plus jn omega t dt. Okay, this is analog frequency omega. This omega w can also be written as omega, but that is digital frequency. Here we are using analog frequency, so this type of omega we are using. Now what I have told you, the sine terms, cosine terms, exponential terms can be used for representing a periodic signal. So here e power means exponential signal. So this is called exponential Fourier series. And here we have sine terms and cosine terms. Which are used, and the a naught is a full constant. A naught is a purely constant value. An, bn are also constant in equation 1. And cos means cosine term, sine means sine term, and combinedly it is called as trigonometric Fourier series. Okay, and the formula for calculating the constants or coefficients are like this. Calculation formulas are like this. If you want to calculate Cn, suffix is positive, you remember suffix is positive. Here in the formula exponential e power should come negative. And the suffix is negative, in the formula e power should come positive. Okay, some blind notations like this you can